Oh, yeah. Yeah. Hello, Kevin. Hello.
Did you try the Khan Academy stuff?
Yeah, I got $100.
I got 100 on the first one, and the other two were like.
That one was so easy. We don't. If we take too much time, then we won't. So let's take a lot of time. Extra questions.
I highly doubt that's gonna happen.
So we'll either have the quiz in the second half of the like in our second period, or if we like ask too many questions or like take too long, then we won't have.
We learned something
We didn't learn it. It was just like
The pretty much we have to stall.
I did the first one, and then I did 2 questions on the next two.
We're going over like those other topics.
in the second period, if we get ready for it, if we like really fast, we're gonna get.
It's fine, ready.
I want to take it tomorrow.
You guys ready for the quiz?
You might not have it if we take it on.
I know, that's what I'm saying.
Hopefully,
That's a question on every single question.
I mean, I want to get it.
No, you're not. You're not ruining it. No, I gotta study.
I
didn't study.
Then I did the next one. There's 2 problems. Got
Give me 2 questions.
What's wrong? What's wrong?
It's
It's gonna be like 8 questions.
It's gonna be like the
I struggled on that Khan Academy. The first one was so easy, but the second 2 were not easy.
I mean,
Those were not easy at all.
They were weird.
I tried it like 3 times and I failed each
I would
time.
get it like.
And I get like one little thing off each
Yeah.
time.
I literally put a T. I put X.
Yes, so did I.
And I was like,
Yeah,
I hated the one where you had to figure out
you have to
the
take it next week.
function and you had to solve.
And yes.
So I was like, if my function
The government won't let college because it's just timing is absolutely.
Oh, yeah.
That one I got right.
Yeah. There's 19 questions.
I'm the first one.
Timing for the other.
I checked it.
Well, it was
There's
more questions. There's more questions than you actually have to.
like the line should grab matches up and everything.
So then.
government-
Yeah, the first one was so easy.
If I get
It was
the last
regular.
one,
You just sit.
if you bring it
Yeah,
up,
I felt really.
Like,
what I did last
like,
night, I didn't see it until 11:30.
Some of the
And then I
people
just
didn't
did
even let you
first
get
one,
on.
and I still had the other two.
My team, you just have to sit there and like do the paper in front of us to just draw.
I didn't like get 100 because when you get 100,
It didn't make it drag in.
yeah.
He's trying to.
I gotta say, for the last 2,
How was
I got
the
I don't
rewrite it.
And I got the last one. I was very, so I just kept
That's
it.
fun.
skills?
Just look over.
Seriously?
Don't go right.
I was like, okay.
And on
The thing you have to do, I know what
Friday.
You did.
you don't get
Look at the sign, like,
but
if you do the signs, like the signs are
right.
Yeah. But there's some questions like, there's some real stupid ones.
Yeah.
Yeah. Drugs, looks like seatbelt stuff. Yeah, seatbelt stuff.
It was like
Because it's like, you don't want to yeah, I said everyone in the class is like, and you got it wrong.
Yes, I was like, I
Some of them
answers for Khan Academy.
Yeah,
You know me,
Right,
I
right.
did it like 5 times.
I did it so many times.
I didn't even think of that. Like, you can go to
Well,
another tab,
maybe.
go to Khan Academy, log in, you can do
I think it was just.
Well, not, you can even be logged in, just bring up the same.
Kind of bumping me up because I got
You
sick.
mean-
Just stay there, just submit your writing.
What?
The other one.
Yeah, I don't like.
Well,
That road like part of this way.
Yeah, they
I
have
feel
some
lost.
I hope he doesn't create it.
I don't remember taking it. I didn't think we'd taken one yet. Maybe we have. I don't remember.
Did we take any numbers on Friday?
No, I didn't do it.
you did that, you looked it up after?
Cause I'm like,
There's gotta be.
yeah, that's what I was saying, it was like, come on, other people probably like cheated this whole thing, I'm like, I just spent like all this time.
Spent like 4 hours.
On one stupid assignment.
Yeah, I said like the last 2 studies.
I can't tell. Spent that whole time on the one function.
Why? The sides are like.
Like a half and a half inch short.
Hey, when are we gonna shave Sam today?
You're supposed to.
One of
do
them.
You get a mohawk?
What's the second rule?
Or get a
I'm
mohawk.
like shaving everything but like a strip.
We're making a really thin strip, like it's like 2 inches.
No, but we make it like really long. It's just so flat. It's just like this. This hair is just like this.
Please. There's no point in writing.
Let's take care. We can't find professional business. Sam, can we just just like literally shave him completely bald. Like get like a razor out and cut the little layers.
And make it shiny. We have to polish
Shiny.
Oh, this guy's really.
Like shinier than this shinier. Windex on your head.
Like it's like a window. So you can like shit out of it. Yes. I think
Grow it back for next month.
maybe we could talk straight into it. I think we do.
I'm not cutting my hair. I see what it looks like this.
Yeah, no, you have the
Jim
White Christmas or whatever.
Jim Carrey.
Dumb and Dumber.
Yeah, we
Yes, I mean, yes. My dad.
What's the second?
Three.
What's the second?
Yeah, that's what we were literally saying.
It's 3 cents. 3 seconds.
Sir, I know my stuff.
If you miss it, exit. What should you do?
Okay.
Alright.
Hello.
See you.
Hello. Hello.
Taking.
Yeah, hit it hard.
Well, hello, Stacy.
Go to Orange Road and you try to weave your way back.
All right. Woo. Ciao. It is Thursday.
So you guys have had some like extra time kind of off, some of you, where you haven't been here, sleeping in a little later than normal, all that good stuff. So we're getting ready to go here. So I'm just gonna try right now. The quiz is gonna be tomorrow, first period when you walk in. And so that I just decided to ask them because we're gonna go over today. We finished the problem about the water wheel, and then I gave you the worksheet that had 2 problems on it. I also want to see what you might want to ask about on if you had anything about Khan Academy. As far as Khan Academy goes, there was some problems on there that the ones that had like the phase shifts on them, don't get so freaked out over those. I'm not going to put that kind of a question like on the quiz tomorrow. But we'll go ahead and talk about those if you want to. And then I have 2 problems that last period I did a little research and we're going to just create. I've got 2 nice periodic function problems we're going to create on the fly. I've got one ready to go already. So we're just going to get you all tuned up for tomorrow's quiz. And that would be that. Take attendance real fast. Get going here. So maybe you're finding your work right now and your sheets, whatever you need. And uh-oh, we're missing Ford. Miss Ford, we're missing a Ford. And that, oh, we're missing Wright. Okay, right? What's that? He was here this morning?
He's skipping.
I don't know.
And that can't be true. All right. Well, hopefully he'll make it here. And, yeah, I mean, both he and Miss Ford. Oh, there's one of them. There he is. Ciao. All right. Now I got to get rid of that. Got to change that. Okay, now we're good. Woo! Okay, so this was one of the new problems, and let's see. What I'm going to say, what is it that you're going to need?
Is this something?
No,
No, no.
I
I actually forgot that.
was the tax.
That was That's just, I think it's like,
This is
that's
what.
just do not. And there's like, I think a little bit more than half of it's like
And I
science.
might stay after
It's
school
the ones
today.
I thought have been,
I might
a lot of them
come
are
here a
kind of
little
just
bit
like.
to go over what we've been doing.
Yeah. Okay. That's fine. At 2:45, I have to go to a meeting, so that's okay though.
Okay.
We'll make it work.
I had to leave the Zoom.
Here is,
Surgery started to have some complications.
okay, that's one we did. And then this guy, his new one, I know I made some copies of those too.
Is this just a drawing on that drawing?
Yeah, you don't, I used it as scrap paper real quick, so you don't need that for anything. I mean, you can still have that sheet out. Aha! That one's from the day.
What?
That,
That.
perfect.
I can stop by tomorrow after school instead if you have your meeting.
That's it. Whatever. You can come in for a little bit after school. That's not a problem. All right. So let's actually go to here because we had started this, correct? And
Yeah,
did
we
we,
finished.
we had done part of this word problem already?
I think you graphed it.
Okay. So we needed to, yeah, my graph's gone. Well, actually, I think my graph is more like, here's the graph. I did that for my other class. I'm just gonna look at that one. So here it is. Didn't we come up with the function though? So is this the function we had right here?
Yeah.
All right. So here was the function for his rotations around the water wheel. Okay. So once I have this, let's go ahead and actually I'm going to put that on the other page. So y equals, what was it here? 34 cosine of pi over 44. Was it x?
Yeah.
And then what I have here, what's the midline at?
12.
So here was our function. So we did this. I want to know, hey, sketch it. It says now all the way to 3 minutes, 16 seconds. So for 196 seconds. I've already sketched here the first what? 88 seconds. Okay? So I'd have to continue this. So what's going to happen in this graph? Is anything going to change, or could I just draw this multiple times and be okay?
It's gonna stop, so it's gonna be flat line.
Yeah. At a certain point, he flips it off, and it's going to stop. Okay? So if we look at this, right here, it says, hey, he stops it when it reaches 2 minutes, 22 seconds. So this would be what? 100. How many seconds is this total? 2 minutes and 22 seconds?
No, that's
140. 142. So from 142 seconds to what? 2 minutes and 42 seconds, which is what? Come on, guys. 242. How many seconds is that? 162. Okay. So he restarts it when his stopwatch says 242, then waves to molecule man as he reaches the 3 o'clock position. Great. Okay, so I know that during this time, he's not going up or down. He's just someplace stopped. Okay? How do I know where he is?
So it starts from the spot that finished at 142.
Okay?
So you have to start it from there, but with a certain amount of time after.
Okay? Okay, so I'm going to go ahead.
It's like a phase shift.
So I'm going to go real quick and I'm going to open up Desmos. And this, okay, so I'm just gonna real quick type in the red one there. Y equals 34 cosine of pi divided by 44 x plus 12. I'm going to duplicate this. Come on, baby, work for me. So this, I'm going to just pull this over here. Let's look at this. So it's red. That's perfect. So here's my function. Got it in radians. So right now I have 0 seconds to 400 seconds. I just happen to type that in. Okay. Let's go ahead and get our graph to look a little better. We also, let's put the water. The water would be y equals what? 0. Correct? Where's the midline at? Y equals 12. So I'm putting all these things on here. Okay. So I'm going to I like that right there. That's okay. Now, I'm going to go ahead and take on this my function. This is something I'm going to just teach you guys to do. I want it to go from 0. I want my graph to stop. I want it to go from 0 seconds to when he switches it off, which is what? 142 seconds. So what I'm going to do is I'm literally right here after this. Watch what I'm going to type. I'm going to use these brackets like this, the ones that look like little long elongated S's kind of, okay? And I'm going to tell it what values of X I want to use. I want it to go from 0, and then I'm going to say here, X, here, and 142. When I do that, notice that it creates it, and it shows me where he stops at. This is where he is, okay? Now, we just said at this point in time, what's going to happen? He's going to stay at a depth of negative 13.695 feet for how long? How long is he going to be there for? 20 seconds. So here we go. Watch. I'm going to do this on Desmos, and then this, because this is kind of nice if you can do this. Y equals negative 13 point, what was it again? 695, okay. 0.695. And I'm going to do the exact, watch what I'm going to do here now. I want to go from 142 to what? To 162. There it is. Check that out. Then what's going to happen? Then it's going to do this graph again, isn't it? So I'm going to take this graph right here, copy it. I'm going to bring it down here. But I'm going to make it go from what? Oh, wrong one. From 162. And when's he going to do this again till? I told you to do it until what?
So 196.
196, wasn't it? Yeah, there it is. Uh-oh. Now, look what happened here. Why is it doing that?
Because you need a different phase shift for it.
What's that?
You need a different phase shift.
I need a different phase shift for it. Oh, how am I going to get that then? Yeah. Plus, so right here I'm going to put parentheses plus 20. All right. I didn't do it. Minus 20. Oh, okay. Oh. Oh, I put 2020. My bad. Oh, I did that. There it is. Woo! All right. Love it. Okay. So there is the path. See how that neat it is? He's stuck in below water there for a little while. Okay. Good, good, good. So we now have this. Okay. Anybody have any questions? What's going on right now in this problem? So now I need to go back here to number 4. Molecule Man Psychic Electrolysis has watched the entire tragedy from his location on the other side of the river. He notices a power, that thing out of the way. He notices power line running across the river supplying the electricity to the water wheel. Wanting to save his friend, he breaks free from the ropes binding him and climbs up a utility pole to cut the power line to the wheel. Unfortunately, when he reaches the top, he cannot see the wheel because of the trees. Having started his stopwatch when the wheel started moving, he uses the trick he learned in Centerville and decides to cut the power when his stopwatch reaches 9 minutes, 1 second to save Molecule Man from drowning. All right, so the goal is, of course, to know when he cut it off, where is Molecule Man? Above or below water? Where is he at? Let's talk about how I'm going to do this. How am I going to do this? What is a nice way I could possibly go about doing this? Ryan, what do you think?
So I did graph the 2 functions. So I did y equals 34 cosine with the phase shift.
Okay, so you're saying you did another graph based upon Molecule Man. Is that what you're saying?
Yes, I did both.
So, okay, so if you wrote a new function for Molecule Man's view of this whole thing, could you tell me what you wrote for that one?
Y equals 34 sine pi over 44x plus 12.
Pi over 44x what?
Plus 12.
Okay. So think about what Molecule Man was doing. Molecule Man was starting him at the what? 3 o'clock position, and that represents the midline. So that's a sine function. And since he's increasing, it's a regular sine function. So this is his view of it now. Okay? So I could graph that as well if I wanted to. Is that going to take into account what happened here, though? No, it's not, is it? Because this thing here is going to screw up maybe. If I just graph this, it would be thinking that he never did what? Stopped it at all again. So what else? Let's talk. Well, what else do I need to think about here? I mean, that's a great function. If there was none of this like flipping it on and off for 20 seconds, there'd be absolutely no issue with this. That'd be fine.
Just add a phase shift to it, -1.
To
The x -1.
So you want to shift this one. Okay, that's an option, I guess. We could try that. Anybody else have any thoughts? Well, I'm going to real quick, I'm going to take my Desmos graph that I was creating for you guys. And I'm going to put that back up there. Hold on a second here. Let me find it. And this. Why am I not logged in already? There it is. Okay. Open graph. All right, so I'm going to put this over here. I want you to look at this one. Okay, so notice on this, what do you notice about this graph here? This is based upon whose stopwatch when you're looking at this? Whose stopwatch is this based upon, this sinusoidal curve? Is that based upon Dr. Evilman, or is it Molecule Man's graph, you think? Which one is it? Where is it at with t equals 0? Time equals 0. It's at the what? Maximum. Who's that got to be then? Doesn't that have to be molecule man? I mean, not molecule man, I mean Dr. H2O? Yeah, okay. So there's his graph. All right, so real quick, let me do this. All right. What about this one? Who's this based upon? That's based upon molecule mans, right? How do I know that? Because it's starting at the, it's starting where? At the midline at time 0. I mean, that's how I know which one is which, okay? Does anybody notice anything about when these times were starting here? I've got 164, 184. Why would that be?
It's 22 seconds after when it happened for Dr. H2O, so it takes into account the sine to cosine shift.
Yeah, so it's all about, everything had to be shifted to the right, okay? But why is it that much time? Why? Because on this one, this one starts at 164. The other one was starting at, get that stupid yellow thing out of the way. I don't want it there. So why is there a difference of 22 seconds is the question. Where did that 22 come from?
It's one quarter of a period because that's how much time it took to get from the 3 o'clock to the 12 o'clock.
Yeah, it's that difference that from the 3 o'clock position to the top. Okay? Oh, okay. So let's see what I have. I'm going to go back to this other graph I had here. This one here. Molecule mans. There it is. So I want you to see what I have here. I've got it as 34 sine 45 over 11x. Now this is, don't freak out over this. Why is it 45 over 11? Anybody know? Anybody know where that came from? On mine? What did we have before?
Pi over 44.
Yeah. Now I'll tell you why. What do you notice this axis is labeled as? It's not in radians, it's in what? Degrees. And last year when I did it, it was afterwards. Like, oh, so I'm going to change this to make it pi over 44 like ours is. Because I want it to be the same. And then I'm going to just change this to, I'll change all of them that way, to radians. Whoa, what is that? Oh, that's because this one needs to be made into pi over 44. All right, there it is. Now it's the same. There we go. Beautiful. So notice here's the first part. And this is what Ryan had said, correct? Isn't that the function you gave me? 34 sine pi over 44x plus 12. So I did what? I went from 0 to how many seconds? Not 142. This time I went to 164. I had to go 22 seconds. And then I went, there's the same depth. Then I shifted it like you guys did the last one. Okay? So what do I notice if I look at my graph? I want everyone to look at this. Where is he at? Ooh. He is where? Underwater. He's at negative 4.294 feet underwater. That's what Centerville trigonometry will do to you. Okay? So we know he stopped underwater. Negative 4.294. All right. So now what I want to go ahead and do. You know the answer to this is he's 4.294 feet below water. So here, 4.294 feet below underwater. Then it says, how much longer should he have waited? Where would I find that on my graph on Desmos? Where would I find that on my graph on Desmos? When I call it back up here. Yeah, where am I looking for? I'm looking for the what? The x-intercept, yeah. So now I literally would want to do what? I have to go back to my graph. I could either change this. Is there any other way that I could do this without having to change those values?
Yes. Go to the last x-intercept. There's a one that's a period, almost a period before it. So the second to last. I think it has.
Which?
So the one that's close to 450, right? If you.
This one here?
Yeah.
I clicked it, yeah.
Add 88 to that one.
Add 88 to this because that's the what? Period, guys. Let's turn that one off. Yeah, because this part right here, this is when he's doing what? Going out of the water. And as we know, that's going to repeat in 88 seconds. So all I have to do is take this time and add 88 seconds to find out when he would get there. But then I'd have to know what? What this one was at again still, right? What this value was right here. 541 is when he turned it off. So he turned it off at 541. He should have waited until 541. He turned it off. What should he have waited till? He turns it off right here at 541. He needed to wait until right at this spot roughly, which would be 454.948 plus 88. You say 532? 542.
Good, that's not
542 point blah, 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 right? So what should he have waited basically? Yeah, it's almost, is it almost 2 seconds? Because what's the next number here? 9. So yeah, he should have waited another, if he would have waited a little bit more than 2 seconds, he would have saved Molecule Man. I mean, he would have saved his friend. Electrolysis could have saved Molecule Man had he just waited, but no, he didn't. Now, again, that would not be a quiz question. That would not be a quiz question. Okay, that is much more difficult to think about that. Okay. Love it. Love it, love it, love it. Let's minimize this. And let's go back now and do these. These comparatively should be the easy ones. Okay? So we'll read this one real fast and we'll do it. Mark Twain sat on the deck of a river steamboat. As the paddle wheel turned, he noticed a dead fish caught on one of the paddles. As the wheel turned, the distance d that the fish was from the water's surface was a sinusoidal function of time. When his stopwatch read 4 seconds, so when t equals 4, the fish was at its highest, max of 16 feet. And then it says it took another 10 seconds before the fish reached that height again. And then it's and then it says 10 seconds max again. Okay, so somebody tell me what information, everything there, what is that giving you? All of this stuff here. This gives me the what? Max. This gives me the, for writing my function, this gives me the what? The shift, right? The phase shift. This gives me the, to go from max to max is a what? Period of a function, right? It is a cosine function goes max to max, but that's the idea of a period. Okay. So let's think about this. Here's the water. And we have the paddle that's going in like this. and it says that this is 16 feet above the water. This is. What is that then? Tell me why. What and why? What do we know? Yeah. It's 2. Why? Yeah, because the diameter is 18. So this down here, the minimum then is -2. All right, great. So write an equation. So where's my midline? Let's just do this. It's going to start at a max. So I'm going to write it as a regular. If I see it starting at a max, I should probably write it as a what? Regular cosine function. Y equals, okay, what's the first thing I need? Amplitude. Anything traveling in a circle, the amplitude is always the what? Radius. What's the radius? 9. Y equals 9 cosine of, okay, here we go. What is my value of B? Pi over 5. It's 2 pi over 10, which is pi over 5. My shift is going to be an x minus 4. And then where is the midline? +7. Once you have your function, then it's just using it, okay? So then on this one, how far above the water is it at 5 seconds? Everybody have that? Brady, you got that one already? 14.281 feet. Great. How about 17 seconds? 4.219. Is that okay? Everybody's okay with this? Then it says, what is the first positive value of time at which the point was at the water's surface? At that time, was it going into or coming out of the water? And explain. So here I'd want to do what? Look at Desmos. Okay. So let's go to Desmos. Look at this. Let's just clean all this stuff out. So y equals 9 cosine. And we do not need all that. Let's just go from zero to, I don't know. So it says on this again, let's read it one more time. What is the first positive value of time at which the point was at the water's surface? At that time, was it going into or coming out of the water? So that would be that spot right there. Is that right? Okay, so what was it doing? It's coming out of the water. Okay, how do I know that? Because the height is doing what? Yeah, it's going towards the max. It's increasing. If it's increasing, it's got to be going up, out of the water. Of course, that means that this would be going back into the water, right? If I want to know how long is the fish underwater, what would you do? If I want to know how long is it underwater, what would I do? Yeah, you go surface to surface, just making sure you go for the part that's where? Under, negative. Where's the negative height? Where's how long is it above water? You'd be going from surface to surface where it's a positive height. Okay. Great. Great, great. Woo. Any questions on that one? No? Then I gave you this one. Okay? The old spring problem. So weight attached to the end of a long spring is bouncing up and down. As it bounces, its distance from the floor varies sinusoidally with time. Ignore gravity and assume the spring keeps moving. In physics, if you take it, you'll find out that's not true. And there's a concept that it starts to slow down. That's something you'll do later on. Okay, and what it does is it dampens it and it starts going like this and starts bouncing less and less and less until it stops. That's what you'll do in physics. Right now, we're just interested in getting our initial function, though. So it says you start a stopwatch. When the stopwatch reads 0.3 seconds, the weight first reaches a high point 60 centimeters above the floor. The next low point, 40 centimeters above the floor, occurs at 1.8 seconds. So write the equation. Okay, so in this information I've given you here, tell me what have I given you in this problem right here that you need to use? Yeah. Beautiful. Maximum, minimum, and half the period. Because the time between a max and a min is always half the period. Okay, here we go. So our max, and I also gave you a what? Probably a phase shift on this one. The max is 60, and that's at 0.3 seconds. The minimum is 40, and that's at 1.8 seconds. So that's telling me then that 1/2 of the period is 1.5 seconds, which means the period, of course, is 3 seconds. If I know that, I probably can do this now. All right, amplitude. First of all, let's find the what? Midline. 60 and 40 divided by 2. What am I going to get? Where's the midline at? What's the K value? 50. What's the amplitude's value? 10. Since I'm starting this at a max, I'm going to write it as a regular cosine, which means A will be what? Positive. So it's going to be y equals 10 cosine of, here we go, the B value. It's 2 pi over what? 3. Does it simplify? Nope, leave it. Times x minus 0.3 plus 50. There's my function. Okay. Here, again, once you have your graph, it's just plugging it in. So at 17.2 seconds, where would you expect this weight to be at? Yeah, Ryan, what'd you get? You say 33 point what?
43.
Oh, 43, as I said, that doesn't sound possible. 43.309. Okay? Tell me where I'm going to be looking on my graph when I do this one here. Right. Where am I going to find this on my graph? What is this really asking you for? Yeah, but what's that? But what's that on the graph I'm asking you? What is this asking you to find on your graph on Desmos? What was the distance from the floor when you started the stopwatch? What do you think, Dylan? Yeah, we're talking about when x equal time is 0. And the initial spot on a graph, the initial place is always the y-intercept. That's all it's asking you for. So you have to graph it and find the y-intercept then. We have it, right? Yeah, sorry. Yeah, Riley? Say it again. 58.09 centimeters. That's just coming from the graph. And then predict the first positive value of time at which the weight is 59 centimeters above the floor. So when I'm doing this, at this point in time, was it going up or down? So my first question is this going up when they started the stopwatch? Like, was it rebounding or was it going down? It was going up. So that would mean that it reached 59 centimeters almost immediately, didn't it?
Yeah.
0.085. Look at that. Woo! Okay. When you come back, you can ask questions about any of those you want. And then I said I have some stuff for us to do in here to get ready. You got 3 problems. One where I've given you a function and you're going to answer some questions. 2 more writing functions, and then you're done. And then tomorrow you'll take the quiz. Yes.
It's like literally, I'll go to bed at like, and I'll wake up fantastic, and then I'll go to bed at and I'll wake up.
You got any such studies going?
So what I had to do was like right? Very big. Ran a couple functions, did that, did all that, did all that. There, did that.
Doing good. Fine though.
Well, it's not long.
I failed it the first time, but then the second time I got one wrong.
Oh, some of them are different.
Yeah.
Mine was like, I did not mind. We were looking at a while ago, very nice. But so he's figuring out,
Returned the string, obviously.
okay, but that's like.
No,
I would
yeah.
probably go that one.
Too.
Slow down.
But
Well, not
you still
really.
gone on a yellow light.
Yeah, nobody really does it. They just go, like, unless it's too.
Well, if you're in the middle of it,
Yeah, you have.
you have to.
Solid yellow. Wait. Yours
Second, get it there, but we'll shift the letter around. Of course, the they will stay in this one out here.
So like you're driving, it's on.
So if you're on the right side of the road, it's on this side or in the middle?
What's on the middle?
Yeah.
It's middle.
If it's solid, you can't change it.
I'll go over the front somewhere else.
There you go. I'll take
Guys, I'm doing.
Who was it?
Hunter.
Oh, is he on the coffee?
Yeah,
He's in my biology class and he's trying to play Hank. Yeah. This prevents. 1, 2. I already got 5. What is he doing? Washing. You should definitely cross it.
But it can be a pay shorts, which is almost expected on those, but not really.
You do give them control of this, you apply the parking brake.
No. That's when
Isn't that what you're not supposed to
You don't
do?
want to.
Yeah,
You don't.
that's what you're not.
That, you only do that.
Oh, yeah, no, is that the emergency brake? Or is that different?
You can use it as that, but yeah. It's like when you're parked on a hill, you want to use it.
Not use off, shift gears, use your foot off the gas.
You don't want to pull the brake while you're.
Yeah, no, when you go, you just start slide.
Yeah.
I read the 50 pages, I got some time on what we did. Because I had to do it today.
What are advisory speeds on? What are advisory speeds?
Just.
Or accident speeds. Is that a thing? It's one of these two.
Wait.
It's saying are two types of speeds, obviously speed limit.
Yeah.
Accident speed signs.
I guess advisory is like, because it's like turning, say like it's like the yellow one.
Oh,
And it's like it's like a 20 mile or whatever. It's just like you should turn 20 miles around this bend.
So accident speed signs must just not be a thing.
Yeah.
Center lane and each side solid. Each side solid yellow line. And a broken. Maybe. No.
That one's kind of
I didn't get what it's saying. Two-way center lane. Two-way left turn. A blind person.
Tuesday night. Just saw these people rise and trash cans. I didn't bring my jacket. He walked by that whole day.
What is the shoulder?
shoulder. When you're
There's been like a couple other. It's been in some questions.
like near.
I think it's like at itself, like the very edge.
So yeah.
Pass another vehicle. The vehicle's turn. No.
There's no. Okay. I don't think they were gonna ask me a question instead of that.
But there was one just.
It's like how many points?
The one before this was like. Oh, you don't think they'll ask me that?
I don't think they'll ask you that question. I think they'll ask you like
The point.
one after like points.
Yeah, one is like how many points? Or in what situation do you get 6 points?
Yeah.
That's from like fleeing.
Yeah, and then there's like one where
It's how many you
I got
get
one where
if
it's
you.
like how far like, should you be like how many feet?
Sure.
Yeah, like as you conquer one, how far
Wow.
does the sign go? I guess.
Yeah, there was one
like
somebody told me they got. It was like how many points can you get to keep your license? 4.
12. Oh, jeez.
It was 12. That's what somebody just told me.
Wow.
If they truck is trying to pass you, you can't help the truck.
Here's the first problem. There. Aha! Try that one out.
Only get one more
Yeah. What's the 70? Oh, you just have to get 70%.
75.
Oh, it's 75.
I think, so you can get 10 wrong. I already have 5. You may not pass another one. And there's a broken with this right lane. 6. Oh man. Then around about you must try. Count. That's the way you try to bake, but is it like different though? You always
I
like,
feel like you can go.
yeah, it's kind of.
Okay, yeah.
I didn't know.
So remember yesterday I said that I would give you, one of the quiz questions in tomorrow would be, I give you a function, and then you have to use the function to answer questions. So this one, there are 3 questions on this one. Okay, and tomorrow's quiz could have more than 3 after the fact, but just this is the idea. As I said, you can use Desmos on the quiz tomorrow. That's not a big deal either. You're going to be allowed to use Desmos. Now, you really wouldn't need Desmos to find the max and min if you know what you're doing, right? Which numbers up there can help you find the max and min? Yeah, exactly. The midline and the amplitude. Right? The max is what?
13.
Yeah, it's the midline plus the amplitude.
13,000.
So the max is going to be at 13,000, right? Minimum is going to be at 3,000. So again, and like I said, you don't have to do it in your head tomorrow. You can use the graphing calculator for that if you want to. But the max is just midline plus the max. So that's the 13,000. And then the minimum is the midline minus the amplitude. Okay. This, now you probably want to be where? And a lot of this you actually could do without Desmos if you wanted. Okay? Just graph it. So when is the population a maximum? Okay? So max. Minimum. Who has the max? Oh, you get the max? No? Okay. Anybody have the max yet? From their graph? It's a what?
Oh, yeah. You're right.
So let's go ahead. I'm going to type this in there.
I just put.
Clear that out.
This thing. Come on, kid.
Oh my. So you can't kind of just figure out.
Okay, so what do we notice?
It's not big. It's way up.
Huh?
It's way up.
It's way up.
Didn't do that.
You didn't know you could do that?
No.
Oh, guys, you should probably know this. This is kind of nice. So if you're using Desmos and you're like at a screen like this, you know, you can scroll in and out if you want to zoom, or you can hit these. if you hit the shift button on your computer, see how I got the y-axis, and see how it gets this double arrow? You can then literally drag it.
What?
And you can do the same thing for the x-axis if you
That
want,
would be so.
okay?
Wait,
As a quick scale, so you literally hit shift, and then you just do this,
No.
that is nice.
okay? So that's a quick way of doing that, okay?
How did I not?
Because no one taught you. Okay, so let's go ahead, and I'm going to change my window here. And I'm just going to go from, now, if I do this, what do we notice? I went 0 to 12. Why, is this what you guys have? Yes? Yeah, no, maybe, what do you think? You have that same graph?
Yeah, I do. But I'm on X100, so it starts out.
You put x to 100?
100, mine's at 1.
So here's why, guys. I want everyone, now this is something tomorrow on the quiz I will tell you, okay? The reason this is because this 30 is in degrees and it's not in radians, okay? If it was in radians, it would have what most likely in it? Pi. Okay? Yeah, and after I put that problem up there, I realized it. So I want to change to degrees, and then I go, oh, now the graph makes a little more sense to me.
Are there
Okay.
any ones where we gotta decipher?
Tomorrow, everything will be in radians. There won't be any degree mix-up tomorrow. Everything tomorrow will be in radians. I'll just tell you that now, okay? So now here is our function. Okay, so now you can answer those questions as need be. Okay, so it says, when is the population a maximum? We notice at what month number 10. And then it says, when is it a minimum? And it's at 4. Okay. All right. So we got those. And then down here it says, what is the population on September 30th? Ooh. What should I put in for September 30th, do you think? So is T, what is T in terms of?
Choose the number of months after New Year's Day.
It's the number of months. So if I put in that, what would I do? How would I get to that point? How many days? First of all, and again, tomorrow I won't make you to remember know how many days are in a month per month. But what is September? How many days does September have in it, though?
31. Finally.
29.
How is it 29? It says 30 in the question.
Is it leap?
It doesn't matter if it's leap year. Jeez.
February.
That's always changed in February.
You guys, do you know how many days are in September?
30.
30. Okay, now, listen up. So on September 30th, you would be at 9 months, at the beginning of the day, you'd be at 9 months and 29 out of 30 days have passed by. I would not, again, tomorrow I'm not going to make you have to think like that, okay? Because I would think of it like that. So T, if I want, for X, or T, I'll put X instead, X is going to equal, if I put in that fraction, it would be, how would I put in 9 and 29 30ths? It would be what? How would I type it in here? Any idea? Oh, that's 2 what? 270 plus 29 is?
299.
299. And then that'd be over what? 30? Notice it's basically where? At the maximum. But the maximum does not occur until when? October 1st. Again, I would not do that to you tomorrow. Okay, it won't be that difficult to think about what are you going to enter in, hopefully. Okay? Boom, there it is. Okay, so what if I asked you, what if I went back to this graph? There's a lot of questions I could ask you. Okay? What if I said to you, for what months is the population less than 9,000? During what parts of the year is the population less than 9,000? Okay, so what would I do on Desmos for that? Y equals 9,000, okay. Okay, so what do we got here? It looks like it's from here to here. So what would we be talking about here, basically?
I think I got 6.77.
For what?
How long? It's less than 9,000.
Wait, did you type in y equals 9,000?
He's saying he did 7 minus the points.
Oh, you just subtracted those. Right, that's how long a period of time it is, right? That's how long a period of time it is. If I asked you, I think what I said was, when is it? So if you said, that'd be how long is it less than that? When is it would be what? Basically the dates or the times. So if I'm thinking about it in times, we know that 0.615 would be during what month? The first month? Okay. So there we go. So that would be 0.6 of 31. It's about the 18th of January and the 19th of January, roughly. And then this right here would be in the month of July. Okay, it would be the month of July, roughly. And then if you just did 0.4 times 31 days there, that's about sort of the 12th, so about July 12th or 13th, roughly. Okay.
How do you remember how many days are in each?
Yeah, I don't
Like, is there a system?
No, is
You
it
can
your
use your
knuckles?
knuckles. Yeah.
You can use your knuckles.
8:30.
I don't know what it is.
I don't know.
I know there's a way.
You go
to do it.
January on the knuckle, and then you off the knuckle is February, March, April, May, June, July. You count August on the knuckle again. September. Oh,
Like
There's more.
okay.
Knuckles are 31s.
Yeah.
Whoa.
Knuckles are 31s.
And then
Wait. Yes, it's
So, yeah. January,
January.
February, March, April, May, June, July, August, September, October, November, December. That's
So the ones on the knuckles are 31.
yeah.
Yes.
The rest are 30s and
Except for
20s.
February.
There's no
20.
Okay. You won't, guys.
There's no
Luckily
one for
tomorrow you
29.
won't be counting on your knuckles. We won't have to worry about that.
Yeah, doesn't it have 29? Yeah.
49 is the leap year. You were wrong.
All right. Let's go ahead and do these last two problems. Okay. So
February is 28.
So this is data I took right off of Google to create these. These are periodic episodes, things that are happening periodically in our lives. Okay, so here we go. So everyone knows, hopefully, that we have the sun, and then we have the earth, right? And the earth does what? Goes around the sun. Right now, when it goes around it, it does not go around it in a circle. It's called an ellipse. Okay. It goes around it in what's called an ellipse, so it might go kind of like this, and it comes back around. It's just kind of like a big oval, right? Here's the thing. It does it every year, right? It takes basically 365 days, roughly, to go around like this, to orbit the sun one time. Okay. During that orbit, it has a minimum distance from the sun, and it has a maximum distance from the sun. And those repeat over and over and over, which makes it a periodic function. Okay? So here's what I know. I know that the minimum distance, I'll just call this the minimum. The min distance is about 147 million kilometers. Okay? About 147 million kilometers is the minimum distance we are from the sun. That happens right around January 3rd every year. 3rd, 4th, roughly, is when it happens. Okay? What? But that's because the axis, we're on our axis, we're tilted, remember?
So we're away.
That's why. Yeah. Okay? So, because remember, if the axis, we're not like this. Yeah, exactly. The furthest, the max distance we are is 152 million kilometers. And that happens right around July 5th. All right? Now, here's what I want. I want you to write a periodic function that would model the distance from the sun at any day of the year. Now, when I say day, I did not say date. Day means 1 through 365. Date is like January 3rd is a date. Okay? So you're not writing January. Basically, this is all based upon what day of the year is it. So on January 1st, we're on day number 1. Okay? Please write a function for that right now. Yeah.
How many days into the year is July 5th?
Say what again?
How many days into the year is July 5th?
You got to figure that out. You can just find out. You can just type in July 5th is what day of the year. I mean, you can. All right. And do not do a leap year, guys. Just do a regular 365. Don't start doing leap years on me. Okay. That's why that January 3rd and July 5th can change somewhat because of leap years and stuff. So. Miss Ford! We were going to send out a tow truck and find you. Where were you? Cool. What'd they write?
So it's chasing me the
All right. Gosh, cool.
How do you remember that?
Guys, it's February 29th.
right?
February.
It's the minimum.
Yes.
Is
Yeah, we're talking about the leap year.
that divided.
No. Just before.
I don't know how to find it.
Which is January 3rd.
This is a month.
How?
Yeah, so the max of July.
Oh. Wait a minute. I did that.
What? Last year? Yeah.
It's supposed to feel like
I think Comic Academy really, I think it's all good. Did the June 7th got the 7. I'm working on the June. I'm pretty sure Comic Academy made June.
Oh, it's the one on your
Why keep it on the same amount of days? Is it 21? Is it 171? January? You're doing it right now. Yeah. Is it July 5th, 171? Did you look it up? No. July 5th. July. No, it's not. Wait, what's it? 100. July. I'm not sure I see the calculator. I just did it. Like I went to the minimum. No, it's
So
not.
it's the third day out of the
I did.
3
January 3rd is 185. Yeah. Riley, you're lying.
What day is January 3rd?
186. Got it twice in a row.
But you're not saying day of the year.
Oh, January 3rd? No, I was doing how many days? Yeah, you're right. When it first started, I was starting at, no,
Yeah,
that's
my
3 days. The other one's 108. Yeah.
So wait, so then would it be,
So if you start,
if you started a minute,
oh, yeah, let's
would it be
that.
this time? Yes.
No, that's
Right?
Yeah.
Well,
You
no,
don't even have to do any of
But you
it.
started the minimum to be a
Negative code line? Because it starts at, yeah.
sign starts at,
Oh, or minimum.
I'm close now. You get ready for your arm, negative how many days? I did, I went for every
Had
single one.
C back.
you're doing like,
I need that.
And that's how you just look up how many days.
so negative
No, I
one.
didn't, it didn't tell me. Well.
186. Wait, what would be the? What could you do it like? Just be 2 pi over 4. I'll just do that.
Yeah, I think so.
So just so that we're all on the same page, what day is this right here, guys?
186.
186. This one, if you don't get this one right, we've got issues.
I got that one right.
Okay? Yeah. Woo-hoo. Day 3, okay?
Yes, I'm literally right. I'm adding the days you have to. No, not the days. We're talking about the midline.
All right.
So hopefully, on this one, guys, this would be a what? I'm going to write this from the minimum standpoint, which means I'm thinking of it as an inverted cosine. So this is going to be a negative value. So it's negative 149.5. Is that right? Isn't that the average of the max and the min? Is that right?
I thought that was supposed to be.
See what?
It's supposed to be amplitude, not the.
The midline doesn't go.
Oh, yeah, that's not there. That's the midline. The 149.5 is. Crazy. So we've got K is 149.5. We've got our amplitude then is 2.5. Okay, it's half the difference. So it's negative 2.5 cosine of 2 pi over 365 x minus 3, and then plus 149.5. Boom, there it is. There's the function. Yeah.
Oh, it's in degrees.
That's, yeah, you gotta go back to radians now. It does.
Are you kidding me?
That's because your scale on the y-axis is way too big, yeah. Now your y-axis only needs to change by 5. 2.5 is the amplitude. That's the distance from the midline to the max or the midline to the midline. Okay?
But the max was 168.
No, look at the
Oh.
Yeah, but the
Not my.
max was 157.
Look at my graph.
Max was 157, 152.
Yep, that's what I thought. How?
Oh, I was.
That's probably-
That's one of those
Yeah,
secrets. I just have to
Okay.
assume, man.
Oh, that's the
No, it's not the
Okay,
same.
so let's type this in here. So I've got negative 2.5 cosine 2 pi divided by 365. 4 or 3? 3.
I used to think that was
Plus 149.
Well, let's go ahead and get our window.
no other.
So I'm going to actually take my x values and go from 0 to 12, and then, or actually 0 to 365, my bad. And then I'm going to go, my y values are going to go anywhere from 147 to 152. So I'm going to go 145 to 155. And then I'm going to change it back to radians, and there I get my beautiful graph. Boom. Love it. Okay? There it is. So, anybody have any questions on how we just wrote that function? No? Alrighty. So I'm going to go ahead. I've got one more.
Yes,
It-
152.
Are you okay, Todd?
Yeah, I'm good.
Okay. So I've got one more we're going to do, and it's kind of, you're going to see a similarity here with what's kind of going on a little bit. So here we go. So this is about Dayton, because this is not the same for every place, but this is about Dayton. So for Dayton, usually, this can fluctuate a little bit, but usually on June 20th is our longest day of the year with 14 hours, 59 minutes of sunshine. Okay, yeah.
You said on we're not gonna have day problems, right?
You're not gonna have what?
Like the day problems.
Right, but just hold on. You're right. Just hold on. Okay. Then, guys, here we go. On December 21st, we have our shortest amount of sunlight here in Dayton, 9 hours and 22 minutes. Okay. So this again, what I want you to think of is kind of like the last one, not days of how many days are in a year, 365 days in the year. I would like you to write a function that models the amount of sunlight for any day of the year. So the first day of the year, the second day of the year, the third day of the year, the fourth day of the year, the fifth. So you're using the same idea of we're not giving dates. I gave you dates for this. I just had to give you something so you can figure it out. Okay? So again, if I said to you, hey, on the 82nd day of this year, how many days of sunlight are we going to have? You could tell me that answer then. Boom. Try this one. Okay? Try this one.
Why don't I don't mean I'm gonna do it.
Mr. Renshaw!
It's a wonderful day.
It is. We're writing sinusoidal functions. You're going to help us?
As exciting as that sounds, I think I've got something to do
Okay. We'll drop in periodically.
with the table.
Yeah, exactly. All right. So you have an option on how you do this as far as like, you can change these. I think Brady was saying he's going to change in the minutes. He's going to write it based upon minutes. And then convert it back at the end, I guess you would.
Thanks.
You also could just write 14 hours, 59 minutes as what? 14 and 59/60ths of an hour. And the other one is 9 and 22/60ths of an hour if you like fractions. If you don't like fractions, that's cool too.
I started in December. I started in December. I didn't even have face shift.
January. Oh, you thought June was the first one? No. Making fun of mine.
How many of you are changing this into minutes?
I did.
Oh, you guys did? Okay. So tell me what this is in minutes. Somebody just tell me the answer. 890. 899. Okay. What about this one over here, Mr. Wright? Completely fine with that idea. Great. Here we go. So what's K? Where's the midline at? 730. 730 or 738?
730.5.
Perfect. Okay. Then our amplitude.
168.5.
168.5. Okay. All righty. Now what? B. Oh, that's easy enough. B is, that's just 2 pi over 365. H, I have to decide. I can shift it to a max or a min. That's up to me. Max. That's a what? A regular cosine. So my value of H then is going to be what? What is June 20th as far as days? 170?
171.
You got 171? 171? 171. Okay, so let's graph this real quick. All right, so 168.5. I'm going to put this, I'm going to turn this one off. So y equals 168.5. We're doing a cosine curve of 2 pi divided by 365. We said it was x minus 171. Is that right? Know what you guys said?
Yes.
And then it was plus
730.5.
okay. So Where's my graph? It's right down here somewhere.
Yeah.
Am I way too far in?
Yeah, it's like,
No, it's up higher.
No, yeah, it's,
the minimum that like.
Oh, yeah, because we'll just do this. Shift.
To the cool thing.
yeah,
Yeah.
magic.
Ah, baby. There it is. Okay. So there's our graph. Let's open this thing up. Okay. Now, what's the midline on this one again, guys?
730.
730.
0.5.
Does anybody know where that would be and where this would be in the year roughly?
Oh, like
So this, guys, here's the thing. I don't know if, this is like, if you guys ever think about it. What I gave you was the winter and summer solstice. That's the winter solstice in December. That's the summer solstice in July. This and this is the vernal or the spring equinox, and this is the autumnal equinox. Okay, and that's what those things are when they talk about them. Okay, if you were to go ahead and look at the number of hours on these dates, they're almost exactly the same every single year. So when you see those tables that tell you all of that information, like how many daylight hours, how many hours, it's all based upon it's a periodic function. That's it. All right. Tomorrow's that you're going to write, I won't have dates where you have to do like how many days. I won't do that to you tomorrow. But I was running out of problems. There's only so many water wheel problems I can do with you guys, so I wanted to do some of the other ones that are periodic. Yeah.
What's the max value of that, of the max?
What is it?
Yeah.
Get rid of that. 171.
Did you get 170? Did you do it?
So that wouldn't matter if it was, because he used the 170.
If I do as a negative cosine here, you can just make a negative here.
I did. I thought it would work. Because it's 10 days behind. What?
If I do a negative, it just flips it.
No, I mean like I went from December.
What was your favorite?
Oh, you mean, so you didn't do a shift of 171 then?
No, I did a shift of 10.
A shift of what?
Of 10 because
You went plus 10 then.
yes, but it's off.
Let me see here. I don't know if I can backspace on this very easily. Oh, there it is.
You just wrong. I think it's plus 12.
Is it, yeah, what day did I give you in December?
21st, so
So you needed to add what, 10 or 12, 11 to that?
9 days would be the 31st. And then one more.
See you guys.
One more. Yesterday was literally a blizzard. So it'd be 10. No, I mean, 10 would be 31st. I'll let try 11.
So I gave you, hold on a second here.
These girls are funky. I was the ski from the hot ground. Oh my God. The kids that practice that. I didn't need it. I would say it was like you just come right in and felt like a sweatshirt. But for some reason my graph is like off.
Well, I had it snowing. It was like super sunny and snowing.
I'm not quite sure why. I have to look at it. Because what you're doing, the way you're doing it should be fine.
Yeah, but because at the top, I've added 11 days. So, and it's at 171.5.
That's my
They're all sitting here.
No.
I had, no, it's not ready. Oh, wait. Yeah, the phase shift is 11.5 or something. I don't know why that is.
360. I have to look back.
I don't know, I didn't check. It's just like, I thought, because December is so close to the beginning of the year,
Right. No, I understand what you're doing. The way you're approaching it's fine.
it just didn't add up for some reason. I don't know what I did wrong.
Let me look at it. But if you would have done that and had that written down, I'd give you credit for it. That technique, 'cause I would know what you're doing.
Yeah.
So that's a good thought. See you guys.